Welcome everybody to the session. I hope you enjoyed the keynote. I think there were some really great and exciting news there about Azure and about Windows 10. So I have the unfortunate time slot. I'm between you and your lunch, right? And today I'm going to talk about diagnosing issues with cloud applications hosted in Azure IaaS and PaaS using Visual Studio. So just to set expectations, I'm not going to talk about how to troubleshoot your VM not coming up in IaaS, because we've seen that's a common issue. I'm also not going to dive into like application insights or operational insights. There's going to be talks this week about application insights and operational insights, so I'd highly advise you to go to those talks. I'm also not covering websites because there's another talk on Friday about websites. So this talk is really about cloud services, V1, and infrastructure as a service, applications running on infrastructure as a service. So before I get started, how many of you are aware of or have used Azure Diagnostics? Okay, quite a few. So how many of you have used it in SDK 2.5? Okay. So today, what I'm going to do in this session, I'm going to talk about doesn't move forward. All right. So I'm going to give you a brief introduction about typical issues we're seeing with cloud application, and this is applicable to both like cloud services as well as applications running on IaaS. I'm also going to give you an overview of what kind of tools we provide in Visual Studio to help you troubleshoot this. A huge portion of this talk will be focused on Azure Diagnostics because this is our free framework, and I'm going to talk about Azure Diagnostics, and I'm going to show you how to leverage that framework to implement instrumentation into your application. And then I also have a bunch of demos. I have actually quite a lot of demos, and I hope they will work. Okay, so with that, let's get started. So one of the most common issues we still see is a lot of developers working on cloud services or building cloud services start with their local environment. So they basically use the emulator to test their application. And then they deploy the application to Azure, and then all of a sudden it doesn't work. And it's really hard for you to figure out why it's not working because it was working in the emulator. So we've done quite some work there, but it's still a common issue that we are seeing through our support channels. So does that sound familiar to some of you? Okay. So the next one is startup issues with roles. If you think about cloud services, Azure Websites has pretty much replaced like cloud services web roles. A lot of people use basically Azure Websites as their front end now, but there's a lot of implementations like IoT, for example, or processing that's still running on worker roles, and that's supposed to be like that. So, and for that, sometimes people install custom software into the cloud service worker role. And then as a result of that, if something goes wrong in the boot up time of your application, you get this nice little sign that says your role is in a cycling state, the role doesn't come up, and you're having issues actually knowing why. I'm going to also show you today how to troubleshoot those issues. The next issue is really performance issues. I mean, we all know that or have seen that. So you basically deploy your application and it feels like slow, it is kind of slow. Sometimes it's really giving you the performance you expect, but then you put some load on it and the performance degrades. And you want to figure out why. The last one is really logical issues. I know like developers never make any mistakes, including myself. Just kidding, I'm a PM. So there is some logical issues in your application that are really hard to like find the root cause of it. And it's really hard if you think about your application is now running in Azure and you want to troubleshoot it. And the next, or the last part is really, if you use large, or if you use instrumentation or tracing frameworks in your code, it's really, how can you actually look at the data? Because if you think about a scalable service, it produces a lot of data, right? You probably print out like verbose messages and not only errors. So there's a lot of data you need to consume. We've also been hearing that there's some problems with, hey, I got way too many data. My service prints out way too many data. I don't even know where to start looking at. So with that, I'm going to switch to the slide that shows basically what you can use in Visual Studio. So for difference between local environment and Azure, it's really, I know it's subtle. How many of you have deployed cloud services, by the way? Okay, so you may have not even noticed it, but when you hit the Publish button in Visual Studio, we bring up the activity window. But sometimes if you go back to the build warnings window, you see a build warning that says, hey, you're deploying or you're packaged an assembly that is not on Azure. So it's very subtle, and I just want to bring that to your attention, that looking at build warnings after you published it is a very good way or first step to diagnose that issue. Then obviously, logging and tracing using Azure Diagnostics, so implementing trace statements there, and using IntelliTrace. How many of you have used IntelliTrace? How many of you have used it with Azure? Okay, so IntelliTrace is basically, and I'm going to show you that later, how you can use IntelliTrace with your cloud service. It's a pretty good tool to do that. So startup issues with roles is a little bit trickier because you need to think about like the startup cycle of a role. So you can do something with logging and tracing. If you're familiar with a web role, for example, you have an on start there, which basically boots up your role. So you can put trace statements in there and they would be caught. But sometimes, as I mentioned, you want to install software up front, like a real startup task. And if that thing throws an error, it's kind of hard to trace it. I'm going to show you today how to do this, how you should properly implement like custom software on your role in order to avoid that. The next thing is really IntelliTrace again, because IntelliTrace is being applied as a plugin, and it's basically there in your machine, on your virtual machine in Azure, and can instrument like your WA worker process or your WA-IaaS process. And the other tool, it's very powerful, is Remote Desktop. Because everything that happens on the machine is obviously logged to event logs. There's also a log directory for the guest agent that sits in the machine. It also knows if some processes failed startup booting, and then you can basically go in there and identify the issues there. Performance issues, logging and tracing again, Azure Diagnostics, Visual Studio Profiler, and Application Insights. So this is the talk Victor is giving this week. It's a great tool, or it's a great service, I should say, for analyzing performance issues. Logical issues, again, logging and tracing, Azure Diagnostics. We have remote debugging. How many of you know about our remote debugging functionality? Okay, quite a few. So you can actually debug your cloud service, although we don't advise to do that, or we don't recommend to do that in a production environment. And then again, Application Insights. So as you can see, those are like really the typical issues we run into in cloud services. And there is one common theme. Like you can catch most of them through logging and tracing. And logging and tracing, we really try to embrace it and take it to the next level. Because we've seen customers that started like they put in a trace statement here, trace statement there, and then the service grows. It grows organically, or it's been like very successful. And then all of a sudden you're there and you don't have the proper tracing in it. And you basically need to rewrite it or add tracing capabilities, redeploy it, and so on and so forth. So that's why I'm going to focus most of this talk on really Azure Diagnostics, because it's the framework, the free framework for logging and tracing in Azure. So what it allows you to do is you can first and foremost implement application logging and tracing. So if you're used to trace.trace error or trace.trace information using system.diagnostics namespace, you can still use that. But if you want to go like one step further and you embrace semantic logging, for example, or event source, ETW event source, this is also going to be caught or being used, or I should say, the Azure Diagnostics agent will also collect your ETW traces and put them in a storage account. So how many of you are aware of ETW event source? Okay. So besides like your application logging and tracing, Windows Azure Diagnostics or Azure Diagnostics gives you another good capabilities, because it also monitors the event logs on your virtual machine. So if you have a cloud service, it's basically a virtual machine underneath, or on your IaaS machine. It captures the IaaS logs, like your typical IaaS logs or your failed request logs, It captures the performance counters. It also can deal with custom performance counters that you add to your application, and I'm going to show you how to do this. It collects crash dumps. It can collect custom logs, and custom logs is something that you would set up if you wanted to install additional software on a worker role, for example. And it collects Azure infrastructure logs. So if you look at this, this is really a very complete, like, free framework for getting diagnostics information out of your system. The other thing is, if you think about like a rich tracing and logging strategy, you really want to test it out locally. So in an Azure Diagnostics, we also have on-premises, or I should say not on-premises, local support through the emulator. So you can basically put trace statements in your code, you hit the emulator and you see what your code is basically printing out, or your trace statements are printing out. That's actually a very good way of testing your diagnostics, because sometimes people think about diagnostics, oh, this is just production. No, but for a really good diagnostic strategy, you want to test it out. And so you can do this locally with the emulator. So how does this agent I was talking about actually gets applied? And the reason why I was asking before whether someone is using Azure SDK 2.5 is, in 2.5 we made a big switch. We actually moved to an extension model. That means if you think about an Azure extension, there is a piece of software sitting somewhere in the cloud and is waiting for command. So what's happening here is, and this is applicable for infrastructure as a service VMs as well as for cloud services, I should say. So you get your role ready, and then you want to enable diagnostics, and you can do it from any client. You can do it from Visual Studio, you can do it from the portal, and you can do it through PowerShell, so as an automation step. What's happening then is the command or the APIs call the extension store and say, hey, I want to enable Azure Diagnostics on that particular machine. Then the extension is being pulled down and is being applied. The good thing about that is it's really very dynamic. So you can apply the extension at any time. Before SDK 2.5, in SDK 2.4, you always had to package the agent and have it move with the app. Now, we basically moved that dependency away, so you're really flexible of doing that, and when you want to apply it. The other thing is the extension itself takes a configuration. So the truth of your configuration for Azure Diagnostics is really just one configuration file. Before, there were also like APIs to configure diagnostics, which led to a lot of confusion, which one has the truth. Like, is it a configuration file, the declarative one? Or is it like the declarative one, the imperative one in the code? So this has all been gone away, or it's all gone away. There's like just one truth, there's one extension and one configuration. So there was a lot of talk. Let's switch to the first demo. So in here I have a meeting the theme of today, IoT. So I have a very simple application. What it actually does is, let me just talk you through it quickly. It's a worker role that hosts Owin and Katana. It's basically hosts a web endpoint. And then the web endpoint or the API gets some messages, sensor data. It's basically mimicking like an IoT scenario. So if I go to the controller here, what's happening is, like, any client can basically call a message and put sensor data in it, and then it starts processing the data, and then it disconnects from Azure. Oh. Let's try it again. Okay, let's try it one more time. No, don't think so. What's that? No, it's coming up. Good thing is I have a local copy, but I might need to switch to that one. All right, let's give it a try. Come on. All right, please. I was expecting having trouble finding the right deployed service because I have so many, but know that I cannot connect. Okay, so we're back up again. So bottom line is it's basically a web endpoint that's hosted in a worker role and that gets messages from an endpoint. So if I go to the message here, store async, this is where all the magic happens. If I look at it, I basically receive the sensor information, I read out the sensor information, and then all the data is being put into a Redis cache. While I'm doing that, here I have a bunch of trace statements in my code. Like, for example, I'm tracing or I'm putting out trace information statements about what the information is that I stored. I'm also going to put out like trace information about the sensor ID and so on and so forth. So it's very typical for developers to put that type of code in there, right? So let me show you now the Azure Diagnostics part of it. So first, if I go to the role, I go in here, and that's what we call the role designer. And in here, I have my service configuration, and you may know that, and go to all configuration. And here I have the enable diagnostics button. So by default, if you create a new cloud service project, or if you start from another one, by default, we always turn on Azure Diagnostics. So that basically means when you use Visual Studio to publish, we'll apply the extension. That's the very first thing that we apply. So then in here, I have this nice little dialog that says, okay, this is what you can configure in Azure Diagnostics. And think about what I was talking about before, like what can you do in Azure Diagnostics. This is basically the dialog that's a UI over the XML, over the configuration file. So we thought we'd make it really easy for you to do this. So in the application logs, here is the application logs. And application logs is really your trace.trace star. Right? So everything that goes through the trace listener is being logged into this application logs. By default, we only set it to errors because, as I mentioned, we turn it on by default. So we don't want you to deploy your service to Azure and then all of a sudden that thing starts spitting out data because your trace statements are being transferred to storage. In here, you can also do Windows event logs, performance counters. So as you can see here, I have custom performance counters in my code, which is basically get the device requests, get sensor data requests, total device requests, and so on and so forth. So I can configure my custom performance counters, infrastructure logs, log directories. By default, it logs the IaaS logs and failed request logs, ETW, and I'm going to talk about ETW later, and then crash dumps. Here you can configure the crash dumps that you want to collect if something goes wrong. And here we have like the most important services. The first one is really the host process for W3WP in a web role. And the second one is really the Azure Worker process. So if something goes wrong in there and you enable the crash dumps, we'll catch the crash dumps for you. Okay? So that's the first part. The second part is, maybe it's worth pointing out, if you don't provide a storage account in here, because as you can see, there is a provide storage account information. If you don't provide one in here, we'll take the storage account that you use to publish the package to. So because Azure Diagnostics needs to get the data off the VM and stores it in a storage account, and what we do is, if you don't have it enabled, we basically use the storage account that you use for publish. Why are we doing that is, think back when I was saying, hey, a lot of people do something in the emulator and then it doesn't work in Azure. That's basically your first inner loop test. We don't expect you to use Visual Studio to deploy to a production slot, but usually it goes into a dev test slot in Azure. So, but then you have at least diagnostics turned on and you could see what's going on. So let's look at the last piece of how diagnostics is wired up. So in an app.config or in a web.config, we have the Azure Diagnostics trace listener, and we set that by default as well. And this is the reference to it. It sits here. Okay? So think about, by default, it's wired up the app config for web roles, for worker roles, the web.config for web roles, has the diagnostics trace listener set up. We'll configure it by default to collect errors. And if you don't provide a storage account, we'll use the storage account that you use for publish. So let's assume I'm done, I have my tracing, and I want to see how it works, right? Because I really want to see how the messages come out. Let's fire up that application here. And so I should say this is Visual Studio 2015 RC, and it's the SDK 2.6 that we will release this week. Unfortunately, if I hit on this now, it's probably going to crash. Oh. All right. So go back here. All right, let's try it again. Hit F5. That looks better. Okay. So here in the output window, I'm getting like some information that says my Azure host is working and so on and so forth. So you get some tracing statements in the output window. But there is also the compute emulator UI, which is here. And if I open it up, this one, I see my deployed worker role instance, and I see all the output. So what I'm going to do now is, I have written a nice little simulator app. That thing basically simulates a bunch of devices and pumps a bunch of messages into that service now. So I'm going to hit OK. So it's connecting to the endpoint, and it's putting the messages into my service. So now if can you guys see that okay? So now if we look at it, I get all the trace statements that I have in my code, and it basically says, okay, the sensor data, like the pressure, the temperature, sensor ID, and so on and so forth. So this should give you an idea how you can actually use the local experience to test your diagnostics features, like trace error information. So the other thing is, let's stop debugging here. Let's go to the deployment. Let's say I'm done. I tested my local experience. I have my trace statements. I see everything is working as I want. So what I want to do now is I want to publish the service. Let me just go in here and grab the URI. What I'm doing here is I just point the little application here to that service. And then I'm going to hit it again, and that should go fast. So the way I would publish it, I assume you all have seen how to publish a cloud service, but I go through it very quickly. So I would go on cloud service, say publish, and then I just go in here. It starts here. I pick my subscription. I see my different slots that I want to have it in. I pick my configuration, pick the environment, and then I basically hit publish. So once the service is published, you're now in that situation that it was working locally. You had your trace statements working locally. Now you want to see what's happening in your live service. So for that, let's switch over to Server Explorer and drill into the service. Takes a while. So This is my simple IoT service. Here I have my staging node, and here I have my role. So on the role itself, I could say view diagnostics data, which would basically do the following. Like if you have a role with multiple instances, you would get an aggregated view of your diagnostics data for that particular role. So it would basically gather all the data or all the errors from all the instances. Because I only have one instance here, I just say here view diagnostics data, and what's happening now is it's basically reaching out to Azure and says, hey, give me all the diagnostics data that's in a storage account that I have defined before. And again, that should bring up what we call diagnostic summary window. So this is the diagnostic summary window. And not getting confused, this is not meant to be like your diagnostics viewer for production system because it wouldn't scale, right? This is really meant to be like, hey, I've done my development locally, I published it to Azure, something went wrong, I want to see an error, or I want to see my logs, and this is really what it means. So in here, I have what I've done is, in the service that I published, I just made a tiny little tweak, and I think every 9th sensor sends an error, just to show you what it does. So if there is an error, because that page only shows your errors to begin with, right? Because we don't want to have like, you have to deal with all the data that's in there, because as you've seen, there's a lot of verbosity as well. So this one here gives you an Azure application log error, and if you look at it, you can hover over it and it says, sensor 5 did not submit any data, right? So for you as a developer, you're now in a position, so you've tested it locally, you published it to Azure, something went wrong, you go to the summary page, and then in the summary page, all the errors are listed right away. So if you happen to have many of those errors, we also have export to CSV, because that summary page doesn't have great filtering capabilities, but we understand a lot of people use Excel for it, so we implemented a button. You can open it, and it basically pulls out all the data from that table into Excel, and then you can use Excel to analyze your issues there. The other thing maybe to talk about, you have event logs and things like that, so everything looks good. The last thing I want to point out here is, let's say for some reason I had unchecked that enable diagnostics checkbox in my project, and now I wanted to test, or now I wanted to collect the data. I can just go to Server Explorer, and in here I have update diagnostics. If it wasn't enabled, it would say enable diagnostics. And if I go to update diagnostics, I see that I get the same dialog that I had locally, and I can basically just apply new settings. So for example, I could say here in my application log, you know what, I not only want to see my errors, I really want to see like the verbose information, and then we're going to write it back, and then what's happening is all your logs are being basically transferred into the storage account, and you could view them. Okay. Does that make sense so far? Okay, so let's switch back to the slides. So this was really a very high-level tour of diagnostics. All your takeaway should be really, okay, if I use system.diagnostics, it's super easy. Everything is wired up for me, right? I can tweak it. So Visual Studio really has your back, I should say. So let's talk about the next issue, which is startup issues. So how many of you have seen that nice little picture down there where your role is in a cycling state? Okay, many of you. So before I'm going to show you how to, or before I'm going to tell you how you could actually diagnose it, I'm probably going to show you how you should do it right, basically installing your software right. So we had customers, I talked to a customer recently who actually does some graphics rendering, and what they do is they basically put runtimes, components on worker roles, because they spin up like massive amount of worker roles to do this graphics rendering. And they were really like having issues with those diagnostics startup things, because some roles just didn't come up. So what we've done is we sat down with our support team, who actually was a great help in showing how to diagnose it, but we also thought, okay, what's actually a good way of avoiding that if you want to put another software on it? And really the way to do it is you should set up your cloud service so that the logging of a startup task that installs something is there for you. So then you could just see it. And I'm going to show you, that's the next demo. I'm going to show you how to do this in a second. So if those steps, those are very high-level steps, you need to add a local storage element to your CSDEF file. You also need to create an environment variable that actually contains the path to your log directory. And then the last step is you need to tell Azure to basically collect the logs from that directory and transfer it into storage. It's a very simple 3-step rule, and I can show you how to do this. And I think today we're also going to have a blog announcement that goes live that shows you exactly how to do this. If that didn't help, the steps you can do in order to diagnose startup tasks is, again, check your build warning, because sometimes startup tasks are due to missing assembly references, right? If you use Visual Studio, and even if you don't use it for deployment, you can use the cspack command, right? Because the cspack command would also show you a difference as an output. The other thing is, what you need to do next, or what you should do, is you RDP into the machine. The good thing about RDP now is Visual Studio, we still package it as a plugin, so you need to enable it in Visual Studio. But if you have forgotten to do it, or you didn't want to do it, like the portal now uses an extension as well, so you can just enable remote desktop on your roles at any time. And then you basically go into your instance, you check the Windows event logs. Usually it's a very, very good source of information, especially if something went wrong. Then you can check the WA host bootstrapper logs. They're in the C resources directory. So this is basically like the whole role setup, the role startup, because what's happening is there's an agent that runs, is a guest agent, communicates with the host agent, and then it says, hey, it gets the information, I have 3 startup tasks, I need to run them, and then it would actually show you when it breaks down. And then if that doesn't help, you can go to the app runtime logs. So usually, this is really the only thing what you need to do in order to get a rich set of information. And this is, I would say, 9 out of 10 cases, you know why your role is cycling now, if you do this. However, there is like this one case that the logs don't show anything. And your only chance, really, there right now, as of now, is you need to install a debugger on the machine, install WinDBG, and attach it to the WA IaaS host or WA worker.exe processes and really debug those processes. Another option is if you have IntelliTrace and you can redeploy, you can try, before you install something on your machine, you can try enabling IntelliTrace in your cloud service project and redeploy your service with IntelliTrace enabled. Because IntelliTrace will also monitor the startup process of the onStart method, but it won't catch like things that happened way before, so installing software. Okay. So let me show you how to do startup logging. For that, I don't need to switch machines now. Going in here. Let's go back here. And let's start a new Visual Studio one. And okay, because it crashed, I need to do this. So in here, this is a Visual Studio project. It only has a worker role, and if you look at the worker role itself, it doesn't do anything. What this worker role really does is, I basically use it as a transport object to install .NET 4.5.2, because we currently don't support 4.5.2 on the guest OS, so you would need to install it. And I thought that's a really good opportunity to show you how to install .NET 4.5.2 on a cloud service instance and show you how to implement proper logging. So in here, the first step I need to do is I go in here in my CSDEF, and as I mentioned, I add the local resources. Here I call it local storage install logs, and I give it like a size, whatever you expect. In that case, it's 5 megabytes. Then I'm going to set up a startup task here, and I say, okay, in that startup task, execute that install command, and that install command is basically a script that installs .NET Framework 4.5.2. Run it as elevated, and task type is simple. And then I basically have an environment variable that sets the path to install logs. And here's the path that we actually want to put the logs in. So this is the very first step. Now, what happened when I add that, I should highlight it, when I add this piece to, my CS dev, once the service starts provisioning, it's being told, hey, I need a local resource, it's storage. When you start up, execute that command, and then also use that directory for logs. So at that point, you're in pretty good shape if your script writes to that log directory. What's not happening at that point is your errors are not being transferred into storage at that point because Azure Diagnostics doesn't know about it. So to make Azure Diagnostics aware of it, you go in here to the role itself, but this time you cannot use the nice little UI because honestly we don't have support for it in the UI itself, so you need to go to the XML. And in the XML, there's this directories element. And it has the IaaS logs and failed request logs. And what you do in there is you basically, in here, you add a new data source and a directory configuration and say, okay, my directory configuration has the name, has a container name. And that's basically a container name that will show up in blob storage. And then the local resource, it points to its install logs. So, and then the last step here is you basically just add the .NET Framework installer and the install command, command script to your role. So in that install command script, you see that we're writing log messages to that directory. So this is pretty much it. Then once you have deployed the service, what you see is you go in here, you go to your cloud service, and going here. It's really slow. So I'm going to go to my cloud service. This is the cloud service that I installed. And in here, you can also say view diagnostics data again. So it's opening up the diagnostics data for this cloud service. And then if I go to the directory list of blobs, right, because IaaS logs, failed request logs, or this one is being transferred as blobs, you get this nice little thing here. And remember, netfx install was my container name. And then I can basically click on it. It's getting the data here, .NET installer, and then I have my startup tasks in here, startup task logs. So this is really the proper way if you want to install software on a role, whether it's a web or worker role, to implement logging. Because as I've seen, if now something goes wrong during your startup process, you have a very convenient way to reach those logs. If that's not the case, you need to go through all that hassle that I showed you before. So that's why I'd highly advise you to do this. Again, we're going to blog a blog about that, and so you can basically try it yourself. And it's really a good way to avoid startup issues. All right, so let's step back to slides. Okay, so now we've talked about how Azure Diagnostics is set up in Visual Studio, how to use the trace class, and how to basically enable logging for startup issues. So for those of you who are familiar with ETW event source, that's another way of implementing logging. And the way we think about it is system diagnostics, the trace class, is really good for scenarios where you have, like, I'd say, a predictable size of data coming in, or when you know you don't have a lot of super high scale on your machine or on your service. So the more you go into a scale upward direction and the more data is getting produced, you probably really want to get some structure in your logs. Because if you look at the the messages of trace.trace information or trace.trace star, it really just takes a string, right? So everything is pumped out as a string. You get an object because you use a method that says it's an error or warning, but that's pretty much about it. You could do it yourself by implementing keywords, but then you have to do a lot of string parsing, a lot of string concatenation. So what you really want to do then is you want to get some structure in your logging, and the way to do this is using ETW event source. So ETW event source is not only like a good way to implement structured logging, but it's also really designed for high scale. So anything that runs, like what Scott Guthrie was mentioning this morning, like Service Fabric, our super hyperscale framework, uses ETW to pump out those events. So that goes a long way. So and we advise pretty much everyone to switch to ETW event source, and I'll give you an example why. So it's designed for high scale, but more importantly, all the operating system components on a Windows system are using it. So now think about, you run multiple processes and multiple services on your virtual machine, or your instance. You just want to have one source where you get your trace statements from, because eventually you could even correlate those events. And this is what ETW event source gives you as an offering. So with 2.5, with the Azure SDK 2.5, we started supporting ETW event source in Azure Diagnostics. And this is actually something we've been working on to get in with the CAD team for a while. Because our CAD team, customer architecture, customer advisory team, they basically look after all the high-scale services. And we figured, okay, trace.trace information or trace.trace error only gets you to a certain point, but you really want to have ETW. So we started partnering with the Azure Diagnostics team, so we took some ownership of the agent, so we have a very close collaboration together, and now we have ETW support, and we continue building on that. So let me show you what that means for your application. Let's switch back. And let's switch back to this machine. All right. Let's close this one. So this is our familiar application here, the device controller that I was using. Nothing has changed. Except now I have a new class in here. And if I go to the class, it derives or it uses Microsoft Diagnostics tracing. And then it has an event source, it derives from event source, and it has an event source attribute. In that case, because it's my simple IoT gateway, I've just given it the name Microsoft Built IoT Gateway. But you'll soon see where the advantages. So the first thing what I'm going to do is I'm going to define some keywords here. I say, okay, because I want to filter the data later on. I say, I know a bunch of keywords that I need to look after. I have requests, I have information, I have errors, and I have some sensor information. So that's what I define in this class, the very first step. The second step is I implement so-called events. In here, as you can see, I just have an info method, and it has an attribute, and it's set to event, because it's my very first event. I give it an ID of 1. The level is, now my mouse stopped working, awesome. So the level is event level informational, but even here you can see I can even set a channel, event channel operational. And then if I go, if I go further down, I have the keywords and say keyword info. So if I look at my code, and I can implement like many events like that. Admittedly, this is like more effort you need to put in your development up front, and it seems to be really cumbersome. But trust me, as soon as you go to scale, this is worth it. And you can see papers from the CAD team leveraging that because we really embrace that. So let's see how a method, an event source is implemented. Let's go to the device store. And in here, I have, this is actually awesome. Oh, no, it works again. So in here, typical thing, I'm going to basically, I reference, I'm going to use logger using statement, and I'm referencing my event source. And then down here, Remember before I had the trace.trace information, and then I put some sensor ID in there. But this is basically the equivalent of it. But it becomes more obvious if I'm going to do this, if I'm going to go to the next one. So here's the entry that's being created. Now, if I would use, or if I were to use trace.trace information, I had to do a bunch of string concatenation in there, right? Because I would need to say, hey, this was the sensor ID, this was the pressure, this is the temperature, right? And then so on and so forth. So in here, as a developer, I just need to know, hey, I created an entry, and the signature of the method tells me what I need to put in there. If I go to this definition, just peek it. Nope. Let's go to definition. Ooh, boom. Okay, so if I go to the definition here, I can see it has the event ID 7, level event informational, channel, operational, info, and then I basically do all the string concatenation and stuff like that in my method signature. So your code is really clean, and all the logging work is being done in your logging class. So let's try it again. I'm going to run this now locally again, just to show you what the outcome of those trace messages is. And for that, I'm going to go back here. I'm going to grab my local ELL. I'm going to start my service. Okay, I'm going to put my local host in here. Save. See it's working. Go to my app and put some messages in there. So I went to the local one, and then if I go in here to my storage account, I have my development storage, which is basically my local storage emulator, and that mimics the behavior of your storage account in production, so you would see exactly the same thing. And that's true for trace.trace information as well as for ETW events. So if I go to the tables in here, I see I have a new table which is called WAD IoT Gateway. And here's the logs table because I still have some log statements in here. But if I go to the IoT Gateway table, you'll see that I have a way richer set of information, and everything is very well structured, and I can even look for task names. So I could have, or I have really rich filtering capabilities. The other thing I want to point out is, how did I enable that? So what I've done in here is, in my local setting, I went to the ETW tab, and in here I basically just set my event source to Microsoft Build IoT Gateway. Remember, that was the name and the attribute of my class. And then I gave it a name, how it should show up in the storage location, which is IoT Gateway. Okay. And then it basically shows up in your local emulator, like in your development environment, as well as in your storage account if you have the service deployed. So this is a really, really good way. So now, switching gears a little, because let's do something funny here. Let's go to the simulator and pump up the message count to, let's say we simulate like 1,500 devices. Because think about, I tested it locally, and now I want to test it in production. That's, again, my scenario that I had before. Now I have seen, OK, it's working. Now I want to test it in production. So I deployed my service. I saved that because it's taking like 10 minutes. So, and then I'm going to have my simulator fire up. I just need to change. Let's go in here, do a rebuild. Go to Open Files and File Explorer. Let's just to make sure I have the right URL in there. Nope, of course not. Going back here, taking this service. That's basically my deployed service that now has ETW event source and not trace.trace statements anymore. And I run it from here. Okay. So this is now like pumping 1,500 or simulating 1,500 devices. But now you may realize we may get a problem here, right? Because this is just 1,500 devices, and you see how many data it's basically producing within a very short period of time. So your constraint now is getting to, how do I view the data? How can I actually make sense out of the data? Because I'm getting so much data now into my system. How can I do that? So, and again, we partnered with the CAD team, and we basically build a connector to Elk. Anyone heard about Elk? So it's basically Elasticsearch, Logstash, and Kibana. So it's an open source framework built by Elasticsearch, I think, that can take huge amounts of data and basically visualize it. So we partnered with them as an intermediate solution, and let me show you this. Going back while this thing is producing it. Back here. And I go to my dashboard and I say the last 13 minutes. So what's happening here is, as you can see, there's a very, very rich visualization opportunity now. I don't want to go too much into detail what the Elk stack does and what you can do. I think the only message that I want to bring across is, yes, we've heard you. We are working on it to make VAD really scalable. As a first step, what we're doing is we're partnering, or we basically build a connector to Elk, so that you can use Elk for your visualization. And then as a second step, we're going to work on the agent itself to make the throughput of the agent that collects the data even faster. So that's the next step, and that's coming shortly after build. So let's look at this thing here a little bit, because it's very easy, and we'll share the repo. It's up on GitHub soon after that session. If I go in here, what you get is basically a download from a repo, and we have a bunch of sample scripts for you. So you don't need to do much in here. So you basically download the repo on your local machine. This is all you get. In here, you get you can set up fancy advanced Elasticsearch clusters, or you can just play around with it. We have simple sample Elk instance, for example. And all you need to do is you basically go in here, you go to the Logstash configuration, and you edit it, and then this is all provided to you. All you need to do in this Logstash configuration is you need to point it to your storage account where the Azure Diagnostics data ends up, and then you basically execute a PowerShell script that's in that thing, and it spins up an instance for you, and you can use it. So it's a very, very powerful tool, and I think why I wanted to share that with you is, okay, we keep investing in it. We heard you that we need to work on this, and this is one solution. Another one, which is along those lines, don't get confused, Microsoft offers great services like that, like Application Insights. Again, there's a great session about it. And Application Insights goes a little bit further, even with telemetry and things like that. But if you're used to the Elk stack, that's probably also a good solution as well. Okay. All right, let me switch back to slides. So now we've seen basically, I hope I've shown you and I've proven you that okay, Azure Diagnostics for smaller applications that don't run on hyperscale, Visual Studio Pro is a really great tool to get you started. Azure Diagnostics is a really great framework to use. And then I went a little bit further and said, okay, this is how it could look like if you go at scale. And that was the last part. And you could use, for example, Elk or any other third-party tool that actually views the data. So just to summarize on the Azure Diagnostics part, the benefits are really it's a free framework. So the agent comes free. The agent runs on Azure IaaS and PaaS. So I'm going to get to the IaaS part in a second, because I haven't talked a lot about IaaS. And that's the beauty about Azure Diagnostics. It's exactly the same thing. And that's the beauty of having an extension. So everything I've shown you, how to configure it, how to get the data from a storage account, everything is applicable. You could even use what I've just shown you at the end, that you can connect your Logstash plugin to that storage account you could even do that for IaaS. So it's a really great tool. So it's by default wired up in Visual Studio, and Azure Diagnostics obviously has many third-party tools that support the entire thing. So considerations, there is a catch though, as I mentioned. So the problem is currently in this version of Azure Diagnostics, because it's tightly coupled to Azure Tables, right? So all the data you collect is being written in Azure Tables. So you're constrained by the input characteristic of Azure Tables, as well as for reads. So there are some limits what you can hit, and as you can think, if you have a super hyperscale system, that limit will be reached or can be reached. So this is one catch. That's the other thing I said we're working on, like making that collection better, allowing you directly from the agent to put the data into other repositories. So this is really it. I showed you the ELK. Let's spend the last 3 minutes to talk about virtual machines. As I mentioned, I haven't talked about virtual machines at all. The reason is it's really the same implementation. You have an extension model, we package the same agent, it uses the WAD CFG configuration file, and it uses Azure Storage for storing data. So everything I was talking about, like the last 45 minutes, is applicable to IaaS as well. Let's switch to the last demo of today, and then I think it's okay. So switch over here and open this one, because I really want to show you something cool, I think. So this here is a guestbook application, and the guestbook application it's very famous. It's almost like Fabricam now. So what it does is the web front end runs on an IaaS virtual machine on IaaS, and it's using a worker role in the backend. But what I'm doing in here as well is, if we go to a home controller, I'm using event source. Go to event source definition, and here I'm logging all my data. Right? So now the first issue that we are having is, in a cloud service world, I have this nice emulator. I can actually test it. I can test my event source data, right? Here, up until now, I couldn't, but I'm going to show you a trick. We haven't fully integrated it yet, but there is a way. So let's fire up the guestbook. Let's, of course, use Internet Explorer. So this should bring it up, and while it brings it up, let me show you something. Scott Guthrie announced Service Fabric this morning. Obviously, we're also building tooling for it. And one part of the tooling is, you see here, it's called Service Fabric cluster. So we have a node in here, and we will have tooling. But with that node comes something really, really great. And I don't have a Service Fabric application whatsoever. But I can go in here and say, view diagnostics events. So now the view diagnostics event, we basically have a local ETW viewer that you can use for any project. Because if I'm going to go in here and say configure, I see my event sources, right? And now, if I go to my guest book, if I go to my guest book and say Boris, quickly, say hi, and I upload an image. Let's go in here, go to pictures, use sign guest book. And go back here, you see those traces are being written out in real time. So the cool part here is, now you can see, because I instrumented my code using event source on a website that will go into an Azure virtual machine. Now you can see, okay, what happened exactly, and you get the structured information that I was talking about before, and you can even filter for it, and you can think like thumbnail, and it's live search. So it's a really, really good tool, and I wanted to show you that. The next thing is what you would need to do in order to make diagnostics work now on Azure, on a virtual machine, is you need to add the trace listener. Remember I showed you the configuration file with a trace listener for an app config or web.config. It's obviously not there because we don't know what kind of project you're creating. So if you just create a simple project, that project doesn't know about Azure Diagnostics whatsoever. So you would need to go in here in your web config, and you needed to, maybe I have it. You would need to add your trace listener here, and you can just copy it and then you reference the assembly. And then you publish it to the virtual machine. Does that make sense? So let me just show you one more thing, and then I'm pretty much done. This is the virtual machine that hosts the website that I was just showing you. The way to enable diagnostics here out of Visual Studio is you can go to the configuration part, and then we have this configuration page. In here, I have extensions, and you can basically grab the Windows monitoring agent for diagnostics. You add it, and what's happening is, well, voila, you get exactly the same dialog. Now you could basically just point it to a storage account in here. It's loading it. Let's go to this one. So I have my everything set up. I would need to add my event source here, as I showed you before. And then basically you hit OK. And then you update the VM, and then your diagnostics is wired up here. So this is exactly the same, basically the same familiar tools, same familiar technologies for PaaS as well as for IaaS. And then the viewing part is, we don't have like a nice summary page for viewing like we have for PaaS, because we don't know which storage account you're pulling it into. So you would basically need to look it up yourself. So with that, because I really don't want to stand in the way of your lunch, so just let me skip forward quickly the slides. So there are a couple other things, like as I mentioned, application insights is great end-to-end analytics, diagnostic service with great dashboards. There's going to be a great session on Friday, and I highly encourage you to go there because it's very insightful, and see what this team is up to, and they've done a really great job there. Then there's operational insights, which is also plugs into Azure Diagnostics and all that stuff that I've shown you. But currently, it only transfers data over from Windows Event Logs and WAD Windows Event Logs table. So basically, it doesn't take your ETW data and things like that, but they're working on it as well. So I just want you to keep that in mind. Those are the two services that we provide, really great. So as a summary, I hope I showed you the Visual Studio tools that are available to troubleshoot PaaS and IaaS. I know this talk was mainly focusing on Azure Diagnostics, but we truly believe if you have a good instrumentation story in your code, you will avoid a lot of those pitfalls in troubleshooting your service once the service scales or gets really successful. I also gave you a deeper look into Azure Diagnostics and an outlook what's coming with, like, we're having an ELK integration, we'll integrate more with our own services, we will improve the agent. So the last part is, there are a bunch of sessions, and I mentioned some of them throughout my session already. There is a session today. It's Surviving Success, Architecting Websites for Rapid Growth. So Mark Sims is doing that session. It's very interesting if you're interested in like larger scale environments. Then Mark Rasinovich himself does a Lessons from Scale Building Applications for Azure. It's also very interesting, goes along those lines. Then Mike Morton is going to talk about what's new for developers in Visual Studio and Azure SDK tomorrow. So he's going to give you an overview of everything. Some of the stuff that I've showed you is a repeat, but he's going to give you a diagnostics overview. He's going to show you our Docker tooling and all that type of stuff. Really great session. And then there's this application insight session, fast and powerful diagnostics, Friday. Highly encourage you to go there. Historical debugging and IntelliTrace. And then the last one was the troubleshooting applications on Azure App Service. That's basically the website part. So there are 2 pointers. Learn more about the SDK. That's the release. I think we should have released it by now, literally, or if not, then tomorrow. And Azure Diagnostics and the ELK stack, what we've done there. That's basically the pointer to the repo if you're interested. With that, I really thank you for coming here. I hope it was informative for you and you enjoyed the session. And if you have any questions regarding that topic that we didn't cover or we haven't covered, like how do I do IntelliTrace, how do I do this debugging stuff, just find me at a booth. More than happy to talk to you about that. So, okay. With that, yeah, enjoy your build.